All right, today we're going to be identifying triangles, segments, and angles. We're first going to start with classifying triangles. So it's important to know that for triangles, we can classify them by their side lengths and by their angle measurements. So let's first look at angle measurements. So you have three different types. You can have an acute triangle, and that means all the angles are less than 90 degrees. So each one of these angles have to be less than 90 degrees. Then you have an obtuse. For obtuse, you only need one angle that's greater than 90, and in this case it would be that one. And then the last way to classify by the angle measure is a right angle. So it's just that. You have only one angle that equals 90 degrees. So that's by angle measure. Another way to classify is by the side length. So if you're looking at a triangle, and if 0 sides are congruent, meaning none of the sides are the same, it's a scalene. And the way that we mark this up is you do a tick mark for each of these. So every time there's a different number of tick marks, that means it's a different length. So none of those sides are congruent. Then you have an isosceles. With isosceles, you need at least two sides that are congruent. So in this case, I marked those two sides are congruent with one tick mark, and this side is different. It's not congruent to the others. So at least two sides are congruent as an isosceles. And then the last way to classify by side length is an equilateral. Well, think of the word equal. So equal means all the sides are congruent. So if you notice here, they're all have the same number of tick marks on each of the sides. And then also too, I want you to realize an equilateral is also isosceles. So if you were to have an equilateral, because didn't we say at least two? Well, if all the sides are congruent, that means at least two. So equilateral is isosceles also. So now what you're going to do is you're going to classify this first part as acute, right, or obtuse. So you should be looking at this section for here. And then this second section down here, you're classifying as scalene, isosceles, or equilateral, and you're going to be looking at the side length. So go ahead, complete both sections, and then we're going to come down here to triangle sum theorem. So that's saying the sum of the interior angles are always going to be 180 degrees. So again, this should be a review, but all three angles inside the triangle should equal 180. So I did the first example for you. All we do is take this, and equal it to 180. And then when you solve it, you see x is 87. So this angle would be 87 degrees. All right, you're going to go ahead, you're going to try these two. Now, for the middle one, you're still going to do the same thing. You're still going to add this, plus this, and you're going to equal all three to 180 degrees. All right, and then there's a trick to this one. You need to find this angle first, and then go ahead and solve that. All right, this next part is a lot of vocab. You don't have to write exactly what I have. You can put it into your own words, but this is segments and angles. So when you're doing segments and angles, the first one is a segment addition theorem. So that's saying the length of the line segment is equal to the sum of the lengths of the smaller segments. So in my example, I have PN plus NQ equals PQ, which basically makes sense. This smaller one plus this smaller one, those two are going to equal the longer segment. All right, then you have midpoint of a segment. So if it says M is the midpoint, that means this side is going to be congruent to that side. So if we notice, if this is 3, this is 3, so that means the total length of the segment would be 6. All right. So segment bisector. So when you see bisector, you know it's going to be divided into two congruent parts. So if this intersects and you get two congruent parts, this side is equal to that side. All right. Then you have angle addition theorem. Again, this just kind of makes sense. This angle plus this angle equals the big angle. So and I wrote it right here for you. But the sum of two adjacent angle measures will be equal to the measure of the larger angle they form. All right, angle bisector. Again, you see bisecting, so you know it's going to split something into two equal parts. So this line, or the ray, is going to make that one congruent to that one because it is a bisector. So again, angle JKM is going to be congruent to angle LKM. So those two are equal to each other. Vertical angles, again, is a review from what you've done before, but it's basically saying that whenever lines intersect, the point where they intersect, the opposite angles are going to be congruent. So this is congruent to that because they're across an intersection point. And then 1 is congruent to 3 because they are across, or the two lines intersect. So there's your examples here. All right, linear pair, you see the word line, so you know it's two that end up making a straight line. So adjacent angles, important for linear pair. So adjacent angles that form a straight line. So you can go angle A plus angle B equals 180. And then complementary angles, they are going to make a right angle. So this plus this equals 90 degrees. They do not have to be adjacent. They can be separate like that. So how I remember it, there's a couple different ways. You can think C for complementary and then make a 90 degree. Or some people like to say C for corner, which is 90 degrees. So just a little trick to help you remember. All right, and then supplementary angles is two angles that form a straight line, and that straight line equals 180 degrees. So this plus this equals 180. So they can be adjacent or separate, like these two. And then how I remember this, or one trick, is you make an S for supplementary, and then you can make a 180 out of it. Or somebody said S for straight, like straight line. So whichever way helps you remember, it's fine. All right, and then good old Pythagorean theorem. So Pythagorean theorem says that if you were to take the two legs, the sum of the squares of the shorter legs, so those are the ones that make the right angle, is equal to the square of the hypotenuse. So that's where you get a squared plus b squared equals c squared, which is your hypotenuse. All right, so we're going to go ahead, we're going to start doing some problems using some of those terms. If C is the midpoint, so C is the middle, that means this is congruent to that. So all I did was I took 2x plus 1, and I added that, or I equaled that to 3x minus 4. And then when you solve it, you get x equals 5. All right, go ahead. I want you to try that one. And again, keyword here is midpoint. Now on this one, it says the measure, that's how you say that, measure of angle 1 is 4x minus 3. So that goes right here. And the measure of angle 2 is x plus 8. So this is going to go right there. So we want to find x and the measure of angle 2. So to find x, I know there's a right angle here. So I know this plus this is going to equal 90. So then I added those together, and I got x equals 17. Now that I know x is 17, I'm looking for the measure of angle 2. So I'm going to plug in 17 for x, and that's what I did right here, plus 8, and you're going to get 25 for the measure of angle 2, 25 degrees. All right, go ahead, and I want you to try those two. Complementary, remember, is 90. Supplementary is 180, and it's just asking you to find x. All right, so now, if BX ray BX bisects angle ABC. The measure of ABX equals x squared, and the measure of XBC equals 3x plus 10. Find x. So remember, if you bisect it, you're going to get equal angles. So this is going to be congruent to that. So all you do is this is ABX, is right there. And then this is XBC. So these are equal to each other. And then when you solve this, since we have an x squared, you need to factor and equal it to 0, and you'll get x equals 5, x equals -2. All right, I want you to try that one. And then notice on this one, it says point S is between D and T. It does not say it's the midpoint. So S can be anywhere in here. But it does say DT is 60. It says DS is 2x minus 8, and ST is 3x minus 12. So since this is not the midpoint, it's just a point on the line, you go this plus this is going to equal the total. So go ahead, finish this, and solve for x. And then you're going to go ahead and you're going to complete those two using all the definitions that you learned. And then that is triangles, segments, and angles.